Welcome to the last chapter. The term fluid refers to both liquids and gases. Flow due to pressure difference regions. Flowing in systems like pipes, channels, streams, and any fluid experiences internal friction known as viscosity. Between its particles and layers. In this chapter, we shall assume the viscosity of any fluid under consideration by looking at the types of flows: streamline or steady flow. If all the any given have the viscosity, then they share the same flow and be represented by a line. A streamline is a curve whose tangent at any given point is along the direction of displacement of the fluid particle at that point. When the streamline and the line of flow is steady or streamline, this can remain steady and more flow as many lines or layers. The flow lamina of the particles in a given streamline or have this velocity, which may be different as particles in the adjacent parallel layers. However, abrupt response severe turbulence fluid. In flow, the speed of fluid particles in a given point value eddy on the fluid particles. Nozzles with rounded like reduce turbulence reduction is even greater with tubes. In general, streamline shapes do not affect the distribution of the streamline. Non-streamline shapes provide or turbulence which particles. Streamlines do not, but are closer together where the flow is moving faster. Is beyond the velocity known Let us now look at the continuity. In deriving this equation, make the following: that the fluid is flowing slowly. Second, that the fluid is incompressible. That is, significant changes in its volume. Finally, that the fluid is non-viscous. The first look at is what we flow rate is also called volume flux. Volume flux is the volume of a given section of a tube of flow per unit time. For flow through a region X, and the average cross-section area is AX. If the distance covered by the fluid per unit time is d, the volume flux through that region will be given by volume flux is equal to area of cross-section times distance, that is AX times dx. Remember, velocity Vx is equal to this plus which is equal to dx over t. Therefore, equal to dx, since t is equal to 1 second. Thus, volume flux is now AX is squared and Vx in meters per second. The unit of volume flux is meter squared times meter per second, which gives meter cubed per second. Next, we look at mass flux. Recall that density is given by mass volume, and therefore mass is equal to density times volume. It's just simple cross. Mass times volume, taking to be OX times Vx. Remember, volume was given AX times V. AX times density of water is U. Flux is given meter cube grams per meter cube, then flux by kilogram per second. Mass flux is the mass of the fluid that flows through a section per unit. Since the is compressible, the region X is equal to the mass of the region W within the same mass is conserved. Therefore, at W is equal to at. So we have mathematically AW VW rho is equal to AX Vx. Cancelling out rho, we shall have AW VW to AX Vx. AW VW AX Vx is also that is A AV, area times volume, is equal to K, where K is constant of proportionality. It can be deduced that for a non-viscous steady flow, the of cross-section of fluid is inversely proportional to the velocity of the fluid. Speed of the fluid increases when it flows from a pipe of big cross-section area and the converse is also true. So let's take an example. Suppose a horizontal pipe of cross area of 40 square centimeters, which also has a restriction of cross-section 5 centimeters. Given that the conduction is 4 meters per second, calculate the speed of the wider section and mass flux. And we are given the density of water is per meter cubed. Solution. Volume flux in the wider section given by AV, that is area velocity. The first thing I know is that 40 squares in square meter. To do that, divide by 10,000. Get 0.004. Volume flux in the wider section is 0.004 times V. Restriction 5 square centimeters per meter 0.004. Then the volume flux is that cross section for the velocity. Then flux is a constant. A1 V1 equal to A2 V2. Therefore 0.00 times V is 0.005 times 4. Divide both by 0.004, then I shall have to 0.5 second. Mass flux is given by density times volume flux. The volume flux is a constant, whether flux for constriction or the wider section is the same. So volume flux is A. So I shall take 0.0005 times 4. So I shall 0.00 cubed per second. So mass 1,000 kilograms meter cube, 0.02 meter cube per second. And the answer to that is 2 kilograms per second. This chapter by saying that fluid flow is a difference of pressure difference between two regions. A fluid will always flow from a region of low pressure. And the illustrated screen. Here, the water flows from to C to B. From A to reduces. This is why the level of water in capillary flow atmospheric pressure is capillary downwards until a balance is established. If there was no pressure gradient, there would be no flow. Also, pressure reduces with increasing speed. Section B is the velocity of water at this point increase, hence lower water. Consequence is that the level of this B will fall lower than You notice how of A and C are not even areas equal, and the reason for this to C and A is there would be no flow. This relation is known as Bernoulli's effect. Provided a fluid is non-viscous, pressure and streamline, and in its velocity a corresponds in the pressure it exerts. Demonstrate that by the rise of tube in oil of the tube at E is small. Observe of water from A to B. At the velocity water increases and hence the decrease below the atmospheric pressure. Due to this difference in pressure, the oil rises into the tube. The Bernoulli's effects in if a light paper is held in front of the and air horizontally over the paper, initially part of the paper is suspended because it's light pressure acting on the balance. The paper velocity gets higher than at the initial state when rotation. Decrease in velocity causes a corresponding decrease in pressure. Paper. Atmospheric pressure acting underneath the paper becomes higher and reduces the paper up. Again, if you blow air, higher speed of air in between the balloons causes reduced air pressure. The balloons by higher atmospheric pressure where the pressure is low. If you blow a light bulb, the blow really doesn't causes reduced pressure. The bulb is of high atmospheric pressure towards the path of the moving where is water. The highest speed along the water column creates higher pressure further on to push the ball towards the pressure region. Now, Bernoulli be expressed as an equation. Consider a liquid of mass M V and let the pressure at a given point be P. Kinetic energy volume is given by V squared. Kinetic energy per unit volume is given by mv squared over 2v. But remember, density is given as mass over volume, and hence kinetic unit volume is given by half rho v squared. Equally, volume is given by potential energy over volume, but potential energy is given by mgh. Therefore, potential per unit volume is given over v. Relation density is mass over volume. Mass is equal to density times volume, and therefore energy per unit volume is given by rho h. The V potential energy per unit volume is h. Bernoulli found that if the liquid is incompressible, non-viscous, and its flow streamline, kinetic energy per unit, potential energy per unit is a constant. This is One of the applications of this principle is aerofoil. Have you ever wondered what makes it possible for an aircraft to fly? Most people probably understand that the wings are the airplane able to propeller drive force. In total forces in an aeroplane, these are lift, thrust, of the shape of the wing. It is shaped like an airfoil called relative wing general lift. When it flows over the air, it's faster at the top than at the bottom. The moving air below puts more pressure on the wing than the faster moving air. Creates Bernoulli's principle. Creates the force of lift and the propeller creates the force. So lift and thrust are the helping the aircraft to fly. The force created must be greater than the aircraft. Disaster. On the runway, high relative wind in the wing is enough to take the plane into the sky. So the relationship between pressure by the Swiss physicist and mathematician Daniel Bernoulli, Giovanni Battista Venturi performed experiments built the flow meter close to and this is how it works. Differential pressure flow restriction integrated in measuring, illustrated here by an plate. Two holes are located on the pipe walls, one before and one after the plate. Two separate tubes connect these holes to a differential pressure sensor. Two pressure chambers. Pressure is in the be precisely measured. If a fluid, the pressure before and after the plate is essential. When fluid flows, its velocity around the plate increases. In the low fluid, pressure decreases. Thus, values are detected in the pressure chamber of the meter, a high and pressure after the office plate. This pressure directs the flow velocity of the pipe, velocity, and the resistance of the plate, the greater the differential pressure measured. Of the Bernoulli's effect is the blowing off of rooftops. The air blowing by has a high velocity blowing from underneath will on that above may be blown up. Yeah.